Going to our last kind of problem that will cover how do you solve question number 4 on the assignment. It's about grading. Grading. You have an area, and this area it's simply up and down. So variable elevation. And let's say you want to bring all those elevation to one elevation called finished ground or final elevation. So we call this grading. And I want to show you what's happening here. So here is our area. And we have kind of a building and the building existing and to remain. And I want to grade the area around the building to elevation 9. Please watch this. So our final elevation after we finish the grading is 9. And we want to find how much volume am I going to generate based on this grading. Now, what we have to do is we need to do a survey, and the surveyor will go and find for us the elevations. So where are the elevations? It's what you see on my plan view. For example, on the northwest side, we have here a 9.8. This number here is 9.8. So what this number is, it is the existing ground elevation. And we've done this every constant spacing. So we went 10 by 10. So here we go. The spacing is 10 by 10. And we simply found the corners, the elevation at those corners. So we have the variable number and we want to bring everything to elevation 9. Now, this problem here, it's the solution for it is kind of very systematic. And I will show you the logic behind the method. Please watch this. So what I will do is I will not really focus for the entire volume. Just I will try to find what is the volume that will come out from only the first cell, 10 by 10. To do so, I will try to show you, I will try to draw here a very simple 3D. So I will take things and I'll try to draw 3D for the problem. And so we have here an area. I'll start here. I'll draw here a polygon. We'll go from here to there, to there, to there, and then close it. And so this area here, it's 10 by 10, 10 by 10. And then at every corner, we simply measure the elevation. So you can see those are the elevations that we measure, okay? Okay, next is I will just simply try to connect, these points, and I will try to connect these points like so. So from this point to this point here, to this point, to this point, and to this point here, and I will simply give it a different color. So this is my existing surface, So, or maybe different color, like let's say green. So the green is simply your existing surface. You want to take this green and bring it to elevation 9. Let's put some numbers, So this number here, it's 11.7. So the elevation on the front here, it's 11.7. Just please be patient. Sometimes, Yeah, so the elevation here is 11.7. The elevation at this front here, it's 11.25. And then at the back, we have the same elevation, which is 9.8, 9.8 here. And also on the other point is 9.8. So I'm hoping that you guys, this symbol 3D, it tells you what's happening, So we have an area which is 10 by 10. So we have from here to there, sorry, the area, the side, this side from here to there is simply 10 meter. So this is 10 meter. Okay, try to move it a little bit. So this is 10 meter. And also this is 10 meter on this side from here to there. This is 10 meter. Now, let me ask you, what is the depth of cut at this point, like from here to my finished ground? Any help?
2.7.
2.7. Why is that? Because remember the simply I want to level to elevation 9. So 11.7 minus 9. Remember, this surface here, all the boys, they have the same elevation, which is 9. So this surface here, the elevation is simply 9. So we know the depth of cut here is 2.7. Can we repeat the same thing and we find the depth of cut at every corner? For example, from here to there. So this will be, I guess, 2.25. And then at the back, we have 0.8 and 0.8, if you agree, huh? So we have at the back, we have 0.8 depth of cut. So this one is 0.8. And finally, I'm not going to do it because it's going to make my drawing confusing. But you guys understand that at this point here, it's also 9.8. Now I need some help. Anybody would help me to tell me how much is V1 and what is V1 is going to be the volume of cut from only one cell, the first cell, the northwest cell. Any help? Any help? Okay, nobody wants to help me, so I will help myself. So look at this, please. I'm going to go 2.7. That is your first depth of cut plus 2.25 plus 0.8 plus 0.8. Now, what you can see, those are the sum of the depth of cut. We have 4, then I go ahead and divide by 4. I'm asking you, what do I have so far? If I add all the depth of cut, the 4 of them, and divide by 4, what do I have so far?
An average.
An average depth of cut, an average depth of cut. I'm asking you, do you think if I multiply this number by 10 by 10, what I'm getting if I multiply times the average depth of cut multiplied by this area of the cell, what I'm getting?
Volume of cut?
The volume of cut that comes out from only this cell. Now, without doing a 3D, because maybe it's for some of you it was so boring, huh? Without doing another 3D, anybody will help me to find this V2, and where is V2? So V2 is the one that comes from this cell next to it. Any help? Without doing the 3D again. So I'm gonna go here and I say V2 equals, V2 equals, I need some help, please. Not very difficult, huh?
0.8 plus 0.75 plus 2.25 plus 2 multiply 4.
Not multiply,
Divide.
you have to divide by 4, that's an average, and we're not done yet, huh? We're not done yet. Because
Multiply
what you
by
have so
100.
far is only average depth of cut. Then don't forget that we have to multiply times 10 times 10 to get a volume, okay? Are you following, guys, so far?
Yes.
Okay, so I'm asking you, do you think, like, you know, I know that I cannot, I can go ahead and repeat the V3, V4, V5, V6, and so on, but this will take forever. Anybody in my class can get some like observation about what's happening? Do we have a common factor? Please look at the calculation. Do we have a common factor between V1 and V2 and V3 and V4 and V5? Any common factor?
100.
Only the 100?
Divide by 4.
Sure.
10
Look at
by
this.
10.
So this is my common factor. It's 10 by 10 divided by 4. Okay, so that's one observation. Remember this, huh? So there is a common factor. Number 2, I'm asking you, you can see here, this 0.8, it shows once, and it shows one time here. This 0.8, it shows one time here. Look at this. On the plan view, I'm going to circle it for you. You can see here, there is a 0.8 depth of cut. Why it shows twice? Anyone to help me? Why this 0.8 here? It shows twice.
That's common between 2 sections.
Thank you so much. It exactly shows twice because simply I've seen it when I estimate V1 and it shows one more time when I estimate V2 next to it. I'm asking you, this number, this 0.8 on the corner, I'm asking you, how many times it will show in my calculations?
One time.
One time. So corners will show one time because you can see there is no square here, there is no square here, there's no square here. It means it will show only one time. Okay, so on the corner, it will show only one time. On the edge, it will show twice, like here and there and there and this and this. All of those will show twice. I'm asking you, anybody will help me and tell me the depth of cut here, which is 2, how many times will show if I keep going along the same method? How many times it will show?
4 times.
4 times. So any point in the middle, it will show 4, like here and there and this point here. Now my question for you, and that's the last question, I'm asking you, this point here, how many times it will show in my calculations?
Three.
It will show 3 times. Why 3 times? Why not 4? Because the building will stay, and so this part here will not be dug. However, only we will dig around the building on this one and this one and this one. So that's why it is shared between 3 squares. This 2 observation, like these 2 observations, number 1, we have a common factor of 10 by 10 divided by 4, and also the observation that some numbers will show 1 time and some numbers will show twice and 3 times and 4 times. This will give us the method. So I'm going to show you the method. The method is very systematic. We build a table, and this table has 4 columns. 4 columns, as you can see on my screen. A column called H1, a column called H2, a column called H3 and H4. Okay, so what is H1? H1 is a depth of cut that repeats itself in my calculation once. Where are those? On the corner. Only the corner depth of cut will show once. There are H2, and H2, what does it mean? It means the frequency is 2. It means it will show 2 times in my calculation. Where? Along the edges. Along the edges, we will see H2. H4 are depth of cut, which they will repeat themselves 4 times. Those are in the middle of the area. And then H3, where the ground kicks in or kicks out. So we will have H3. So what we do is we follow a very systematic way. Remember, if you go random, for example, if you tell me here I have 3.6, which is H1, put it in the table, probably you will make a mistake. So what is the best way to avoid any mistake? Please watch this. You have to pick a start point. It doesn't matter where you start, but pick any start point. For my demo here, I chose the southwest corner of my ground to be the start point. And what I did is here we can see what is my depth of cut here. Any help? What is the depth of cut here? Any help?
3.6.
And you can see 3.6 and it's in the corner, so it goes into H1. So here is 3.6. Now I proceed to the north. So I'm asking you, what is my depth of cut here? Where the elevation is 12.3, I want to go to 9. So what is my depth of cut here?
3.3.
And it's a long edge. A long edge, it means it will repeat twice and it goes into H2. And what I do is I keep proceeding. I go to the next one until I go to the northwest corner and then turn it to the east and then go to 9.8 and I go south. And I go in a zigzag way until I finish all the numbers on my plan view. By that time, you will see your table is full. And one thing, please do it. Please check how many numbers do you have. Please check how many numbers. So please make sure you count the numbers on the plan view. We have 25. You count the number on the table, you will see 25. It means I have never missed any number. It means I'm okay. So what's next? What's next is we'll do sum. We will go and find the summation of H1, the sum of H2, H3, and H4. So very simple. It means you add 3.25 plus 3.35, and then your number will be here. And then same thing. You add all these numbers, and you place your number here. And then finally, your volume, as some of you already expected, the volume will be, what was my common factor? What was my common factor? It's 10 by 10 over 4, which is here. That's your common factor. And then remember, H1, it's the depth of cut that's repeated once. And you can see we have 1 here, but we don't write it. 1, we don't write it. But H2, every one of those H2, it's multiplied twice. It will be repeated twice, and that's why we multiply by 2. And then plus 3 multiplied by the sum of H3, plus 4 multiplied by the sum of H4, which means mathematically we take this number multiplied by 1, and then plus 2 multiplied by this number, plus 3 multiplied by this number, and then plus 4 multiplied by this number, and whatever we get, don't forget we multiply by 10 divided by 4. Are you guys following? Does the method remind you with trapezoidal? Trapezoidal, by the way, was the same thing. If you remember, it was the common factor, which is simply g over 2, and then you multiply here by the first plus last, which will repeat twice in your calculation, plus 2 multiplied by everything in between. Remember, trapezoidal kind of stopped here. In this calculation here, we have also some numbers will repeat 3 times, and some numbers will repeat 4 times, and that's why there is some extra term in your equation. Again, this is very, very similar to what we've done using trapezoidal. And again, as I said, trapezoidal is not a rule. It's not a rule. It is someone who is a little bit smart who figure out some observation and try to shorten the calculation. Okay? You guys following so far? Should we proceed?
Yes.
Okay, so here is one very common mistake. Please take a look at the numbers in the table and the numbers on the plan view, and you will see they are not the same. Do you agree they are not the same?
Yes.
One common mistake, very common mistake, and sometimes I really feel bad for my students if they do so. Some of my students, what they do is they take the numbers on the plan view right away. They take these numbers and put them in the table. Is that right or wrong?
Wrong.
Wrong. So please take a note, please take a note that what goes into the table are the depth of cut, not elevations. Not elevations. You must find the difference between existing ground and then finished ground. You get the depth of cut, then you place it into the table. Elevations do not go into the table. Okay. One more observation before I go to the next step is, or next example is, I'm asking you, if I want to repeat the whole problem, but I scrap this number here, like the 9, and I turn this one into 14. Can anybody tell me, do you have any difference in the method? So if I change my mind, I want to level the ground to elevation 14, 1, 4. The method will even change, or the method will be exactly the same?
It will be same. It will be filling.
Okay, perfect. Look at this number. The 14 is higher than any elevation of the existing ground. It means the entire area will be filled, and there is not a single difference in the process. You will have to build a table. You go from H1 to H4. You go in a very systematic way, like a zigzag. You put all the numbers on the table, and then you finish. No change. Okay, perfect. Now let's move on to a little bit more difficult problem, where what if my finished ground is not constant? So in this problem here, my finished ground is level the same, 9. So all the points should be 9 after you grade. So I try to make things a little bit more difficult here. And I say, okay, what if the north side is 9 and the ground slopes, that's after you grade, by 2% to the south? You know what happens? There is no difference. Please watch this. Okay, so I built here a diagram for you guys, and this diagram is your final grade diagram. In the last problem, to be honest, I felt so bad if I do it for you, because everything will be 9, because everything is 9. So all those numbers will be 9. That's why you can do quickly by mental math probably, But in this case, because I have a variable finished ground where the north side is 9, so you can see this line is 9, all the points are 9, and we have a slope of 2% down. It means if I go 100 meter, I lose 2 meter. And remember, between the cell side is how much? How much is my cell side? It's only 10 meter, So I'm asking you, in 10 meter, how much do I lose? In 100, I lose 2 meters. In 10 meter, how much do I lose?
$20 centimeters.
20 centimeter, and you can see we went from 9 to 8.8, and then another 20 centimeter, so 8.6, and then 8.4, and finally 8.2. So what you see here is a final grid diagram. Remember, I didn't need to do that for the first problem because you can see everything was 9, so it was easy. 9.8 minus 9, it's 0.8, and so on. Okay, so in this case here, since my finished ground is variable, then I will also have to build myself another diagram called final grade. Anybody will tell me what should be the final step? Look at this. So I have two diagrams. One is called existing ground here, diagram that comes from surveying, and this one comes from my design. I still have to build another third diagram, which is something called depth of cut or fill diagram. So all you have to do is you need to find how much is my depth of cut. For the first problem was so easy because your final grade was constant, so all the elevations will be -9. In here, you have to be careful. For example, watch this. What if I want to find this number? Remember, it doesn't exist so far. I'm going to hide it. So this number doesn't exist so far. I want to find this number. I'm going to show you how. So you go to the same place. So this was the third from the top. So I'm going to go to the same place, 1, 2, 3. So this was my finished ground, my existing ground, 11.9. And then on my finished ground was 8.6. So all you have to do is subtract 11.9 minus 8.6. Any help? Can somebody help me?
3.3.
3.3. So guess what? I come here, I hide this one, we have 3.3. This is how you fill your difference diagram or depth of cut diagram. Now, once you get this diagram, I'm asking you, any thoughts on how to find the volume? No new. What you have to do is build a table, and in the table, classify your depth of cut into H1 through H4 using a systematic way, where you pick a point of start, like here, the southwest, and go along a systematic way like zigzag until you finish all the numbers on your plan view. Then finally, you use this simple equation, which is the cell size divided by 4 multiplied by sigma H1 plus sigma H2 plus 3 sigma H3 plus 4 multiplied by sigma H4. Okay, we're very close to finish, and that's the last part of our lecture today. We already discussed here before that if I change my mind and if I go to elevation 14, some of you said the method will not change. The method, so if everything is cut or everything is fill, it means the method will be the same. How about if I have cut and fill on the same problem? I'm going to show you what to do. Before we do so, I'm going to give you some time. Look at this, please. So here is one area, and the numbers in red, those are existing ground elevation, and we want to level the ground to elevation 10. My question for you is very simple. Would you expect to get all cut or all fill, or a mix between cut and fill?
A mix.
Thank you so much. A mix, which is not very difficult. All you have to do is find the minimum elevation, find the maximum elevation, and if your grading elevation is in between, normally what you'll get is cut and fill. If your grading elevation is above the maximum, it means everything is fill. If your grading elevation is below the minimum, it means everything is cut. Do you guys agree?
Yes.
Okay, now I want to be very specific before I proceed. I want to be very specific. This problem, we have two different questions. This, what you see on my screen right now, we have two different inquiries or questions. One is, where is my cut? Where is my fill? Where? I'm not asking about how much. I'm not asking you to tell me there is a 20,000 cubic meter of cut. No, I'm asking you where. Show me on this area. Where is the cut? Where is the fill? And some of you will question, is that an important question? Like, is that important question to show where are you going to cut and where you're going to fill? Any help? What do you think? Is that important question we should answer?
It is.
It is important question. And some of you probably don't get it, huh? It is an important question because think about how we build this on site. On site, we have graders, and the graders are trying to move the soil around. So what kind of direction we should give to the grader? Move the soil from where to where? We can do that by answering the question, where is the cut, where is the fill? I'll show you how. But the other question is, how much is my cut? How much is my fill? How much cut? Like, give me the numbers, which is also equally important as where, because we have to pay them. We have to pay them and give them some money. So we need to understand how much is the cut, how much is the fill. So I want to be clear. Guys, I'm going to teach you how to find both of them, how to answer the question where and how to answer the question how much. But please be careful. I will not I will not bring these questions in the exam when it comes to how much. Like in the exam or the assignment, I will not ask you to find how much if there is cut and fill together on the same problem. The reason why I avoid that, because simply it takes more time to do that. However, I'll teach you everything, but in the assignment or in the exam, I will not give you any problem that has cut and fit in the same problem. Okay? Because it takes more time. However, I still ask you to show me where is the cut, where is the fill, without calculating how much the cut and the fill. Are you following?
Yes.
Yes.
Okay, so let's start with number one, because number one, you cannot solve number two without answering number one. So we have two questions, where and then how much. You cannot find how much before you answer the first one. It has to be in the same order. Where you have to say, where is my cut, where is my fill? To answer this question, watch this, please. Watch this. So I'm asking you here a simple question. At this point, if we want to grade, remember we want to grade it to elevation 10, elevation 10. So here is my grading elevation. I'm asking you, do we have cut here or fill? Cut or fill?
Fill.
Thank you. That's true. That's fill. True. Thank you. Fill. Okay. And now, how about at this point here, the elevation of the existing ground is 10.5, and I'm asking you, do we cut or fill?
Cut.
Cut. Now, here is the answer, the final. Is there any point along this line, where we have no cut, no fill? And where?
Yes, where the black line intersects.
Okay, I mean, remember the black line is your final answer. Remember that you will be given this without the black line. I want you to tell me where. I guess the answer is here. If one point here along this line, the elevation is 10, the elevation in the existing ground. So the existing ground is 10 and the finished ground is 10 as well. It means I have no cut, no fill. Would you agree? So if I am able to find here along this line a point that has elevation 10, what's special about 10? Because 10 is my grading elevation. And I'm going to find where on the existing that I have the same elevation, so it means I have no cut, no fill. And remember, what is this point? It's a point on contour line 10. Because remember, contour line 10 is a line connecting all the points of the same elevation 10. Do you agree?
Yes.
So really answer here to find where is the cut, where is the fill. It's very simple. Just you have to do is draw contour line 10. Once you draw contour line 10, one side of this contour line will be cut and the opposite side will be fill. And along the line, it's simply there is no cut, there is no fill. And that's what we did here. You should be able to draw contour line 10 by finding and interpolating all these points along the lines and connected them. And so simply this will draw for you contour 10. And you can see one side, all the elevations are below 10, and the opposite side, all the elevation above 10, which means this will be cut. This will be fill, and this will be cut. And you can see here, there is a legend. Look at this legend here. So anything that you see a hatch, it means fill. Anything which is white, it means cut. So we have answered the first part, which is where. How do you answer this part? Very simple. Draw contour line. Which one? Should I draw contour line 10 or 9 or 6 or 7 or 11? Not all of them. It's only one contour line, which is the contour line of the grading elevation here, 10. Now, we've answered the first one. Let's go to the second one, which is I will avoid in my exam, in my assignment to ask you, tell me how much. I could ask you, show me where, but I promise you, I will not ask you how much. Not because it's super science, I'll teach you right now, but because it takes more time. There is not enough time in the exam to do that. Now I'll show you. Now, guys, I want you to imagine that, you know, the volume of cut, it's from here to there, okay? This is your volume of cut. I'm trying to show you the boundary of the volume of cut. We're almost there, huh? So the volume of cut is simply this one. Do you agree or disagree?
Agree.
Okay, so I'll move it to the side. Can we find this volume using the method I taught you here? Please tell me yes or no. Can I find this total volume in one shot using the method I taught you? Think, please, you answer before you answer,
Yes.
please. Can you do that in one shot? Or you can do partial of it, like partially?
Partial.
Guys, remember, this method is based on, there is a common pattern that's repeated, which is the square here. I'm asking you here, this is a full square, like we have areas here, which is full square, and some areas, they are partial, huh? Would you agree? So that's why, because there are some areas which is not full square, I will have to split my volume into few volume. This volume here, which simply I can find using the method I taught you, you know, a few minutes ago. I'm gonna give it color so you can see the green can be estimated using the method I taught you, because simply those are complete squares. Now let's do the partial volume, the small ones, which is this one, for example. So I'll go from here to there, and then to there, and then close it. I'm asking you, can I estimate this volume here in blue using the method I taught you 5 minutes ago? No, you can't, because simply it's incomplete square. But I will show you how. Before I do that, let's look at the green. Now I want to find the green. What will be the base area? Okay, so the base area will be 20 by 20 divided by 4. Huh? So every one of these square is 20 by 20. So 20 times 20 divided by 4. And then we have to build our table, H1 and H2 and H3 and H4. I want to ask you guys, what is my depth of cut here? My elevation is 10.54. So when you subtract 10.54 minus 10, it means I have depth of cut here of 0.54. My question for you is, what do you think? Is that going to be H4 or H3 or H2 or H1?
2.
H2, that's correct. Why is that? Because simply you have to think about complete squares. You can see the 0.54 is here, and 0.54 is here, and you can see it's going to be between this rectangle here. So this rectangle, that's one rectangle. I'll give it color, let's say yellow, and another rectangle here, which is this one here, another rectangle here in yellow as well. However, the other ones are incomplete, so please don't think of 0.54 here as H4. It's H4, yes, only if those are complete squares. So the 0.54 will go into H2. Now I'm going to confirm your observation. I'm asking you, this depth of cut here, is it H1 or H4?
H1.
H1. How about this one?
1.
Okay, how about this one? H1, okay? And now let me ask you, how about this H depth of cut here?
4.
4. Why is that? Because there are 4 complete squares, huh? 4 complete squares. And what happens here is that we're almost there, so you can find the volume coming from the green area using the method I taught you a few minutes ago. How about here? Let's find those small partial volume. I'm going to clean things out. I'm just going to make some cleaning. You guys can see, huh? Now, what you have to do is nothing super. Watch this. I'm going to write here equation, and please correct me if I'm wrong. I'm going to say V, let's say V2, where V2 will come only from this small partial volume. I'm going to say here 0.5. Sorry, bracket 0.5. So what is 0.5? 0.5 is the depth of cut where the original elevation was 10.5, huh? And then plus, any help?
0.5, 40.
Thank you, 0.54. Are we done or not yet?
Not yet.
Plus 0, plus 0, because remember the other points, simply we have 0 cut and 0 fill, huh? We have 0. And then we divide by 4. When we divide by 4, we get an average depth of cut. Average depth of cut. And then finally, we have to multiply by certain area. I'm going to write it here, area, and I will show you what this area and how can we find it. Remember, what is this area? Simply, the area is the blue one, huh? So the area, simply, this area is the area of the blue, okay? Which is simply the area of this trapezoidal shape. Would you agree? Are you following?
Yes.
Okay, so now the final question is, how can we find the area of this blue shape? It is not super science. Watch me, please. Since you have already drawn the contour line, so the contour line is already drawn on you. So what happens is you probably know what this distance is. Would you? Or what do you think? If I say here, let's say you figure out that this is 15 meter. I think in the process of drawing contour line, you already figure out your x, huh? Which is how far your contour line from the end of the line. So let's say this is 15, and let's say this is 7 meter, okay? So let's say this is 7. How we can find A? I'll show you. So guys, I'm gonna come here and I'll show you how much is my A. A is a trapezoidal, so trapezoidal is simply 15 plus 7, and then we go back and divide by 2, and then multiply by the height. Anybody to help me? How much is my height?
20.
20 meter. Thank you so much. And we're done, by the way. We figure out our V2. Okay. And you guys can imagine what we have to do is we have to repeat the process one more time. We have to find here what is my volume here, and 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 simply add all those partial volume to whatever volume you get from the method from the green, and then you're done. Now, there is something I want to mention in the last 5 minutes. It's about your assignment. So I'll come back to here and I will quickly try to clean. So I'll clean this thing. In the assignment, you will see kind of copy and paste problem in the assignment. The only difference is, if you had time to look at over the reading week, is that the corners of in the assignment, they are chopped this way or chamfered this way. It means on the corner, it is incomplete square. On the corners only. On the corners, it's incomplete square. I think by now, some of you already figured it out. How can I solve this problem? Please watch me. So what you can do is you can say, okay, you know what, for now, we'll just forget about the triangles on the corner. I'll go here. I'll do the same thing like I did before. I'll come here, okay? And I will try to find only the volume from complete squares, okay? Please watch this, so in yellow. So this is a complete square. Forget about triangle for now. Forget it totally for now. You're able to use the method I taught you to find the volume in the yellow part. Now, once you remember, I want to make sure you guys understand. This height here, is it H4 or H3?
3.
3. How about the height here?
3.
How about the height here, the point H here? Is it H2 or H1?
1.
Okay, now I think you should be able to do that. And the last part is you want to find the volume from triangles. I'll call the volume from triangle number 1, I'll call it V2. Okay, where V2, it comes from the northwest triangle. Watch this, please. I need some numbers. So I'm just gonna delete this yellow number here, yellow polygons. Now watch this. So V2, and remember V2 is simply this volume here. So how much is my V2? Watch this, is going to be bracket 0.8, that's one depth of cut, plus 2.25, that's another depth of cut, plus 2.7, so I have my 3 depth of cut. Any help? What should I do next? Should I divide it by 4 or by 3?
By 3.
Because it's a triangle, by 3, we have 3 of them. So now I have an average depth of cut. What's next? Should I multiply by the area of the square or the triangle?
Triangle.
Triangle.
Triangle, which is 10 times 10 divided by 2, because the area of the triangle is half of the base times the height. Half base times height, which means half 10 times 10. So this will give you V2. You repeat the same thing on the other corner, which is V3. So you come here, you do the same thing on this corner here. So now you have V2 and V3. Those are the volume of the triangle, plus V1, which comes from the method. You add them together where you get your total volume. I know that you learned a very similar problem in estimating, probably with Wendy or some other instructor, and some of you learned that they call this one H1.5. They call this one H1.5 because it's complete between 1 square and half a square. Please follow the method I just mentioned, okay? Don't confuse yourself, because I know some students, they try to do that, which is correct, but they get wrong number because they cannot remember what they did in Wendy's class. Okay. Any question? We have 1 minute. Any question? Guys, with this, simply you're able to finish 100% of your assignment. Please start. If you have any question, let me know. And as I said, next class, we will do Civil 3D training, and we will also set the time for our midterm exam. Thank you so much, and have a wonderful day.
Thank you.
You too. Thanks.
Thank you.